Good morning, good afternoon, and good evening to everybody joining us today. So my name is Arabella David, and I'm here with Salesforce. And welcome to our webinar today with Christoph Konrads, and he'll be discussing Lightning and Lightning components and best practices. And so if you're ready, we'll get started now with Christoph. So here we go. Welcome.
All right. Thank you, Arabella. And good morning, good afternoon, good evening, everybody. Before we start, I have to show you this slide, as you know, and that's simply a reminder that you should make your purchasing decisions based on currently available features in the product and not forward-looking statements that I may make during this presentation. We would like you to go social during and after this presentation. So we are at Salesforce Devs on Twitter. I'm at Conrads on Twitter, and the hashtag for today is ForUsWebinar. And with that, we're gonna get started. So the agenda for today, we have a lot to cover. We'll start with some data access strategies and how that impacts performance. We'll speak about instantiation of components and how that impacts performance. And then we'll have some specific items around events, lists, and core components and things like that. So let's get started. Sometimes you want to be very sophisticated about improving the performance in your application, but the biggest bottleneck may still be the network latency. And really what you want to do, the first guideline, maybe the most important one, even though it's not the most exciting one, is that you need to make sure that you limit the amount of round trips to the server, and that you think about maybe other ways to get the data and really go to the server as the last resort. Like, for example, if you already have a data set at the client side and you need to sort or filter the data in a different way, use JavaScript to do that at the client side. Don't go back to the server just to resort or filter a data set that you already have. If you need to go to the data, you really want to pay attention to limiting the amount of columns that you retrieve, so only the columns that you need, and the amount of rows that you retrieve. And then the most important guideline that we will focus on in the next couple of slides here is that you should really try to cache data whenever possible. So we're going to spend a couple of slides here talking about data caching. And the Lightning Component Framework has two options that are built into the framework to provide data caching at the client side. The first one is storable actions, and the second one is the Lightning Data Service. And then you can also implement your own custom cache, and we'll talk about that and see when you may want to actually do that. So let's focus on storable actions first. So storable actions is really a traditional RPC approach, so essentially a remote method invocation. So the code that you are seeing on the screen here is the typical syntax that you would use to invoke a method in the server. And of course, these calls are asynchronous. And when the data comes back from the server, you're going to be, this callback method is going to be called, and you're going to be passed a response. So to use storable actions, you use the exact same syntax. There is one more line of code that you need to add, and that's this one. You're basically marking the action as storable. And when you do that, that simply tells the framework that you want to store the response that you get from the server in a client cache. And the basic principle of storable actions is that if the same component or another component is going to make a call to the same function again with the same set of arguments, we shouldn't go back to the server at that point. We should really get the response from the cache. Now, there are two important parameters that you need to know that are related to that client cache. The first one is refresh age, and the second one is the expiration age. So if the data has been in the cache for less than 30 seconds, the data is considered fresh, and we'll explain what that means in a second. However, if the data has been in the cache for more than 900 seconds, that's 15 minutes, the data is considered expired. So now that we know that, let's take a look at some specific examples, and that will all make sense. So the first example, maybe the first time you call a method. So the data is not available in the client cache yet or is expired. So here's the way it's going to work. Your component here on the left is going to say, okay, I need server data, so I'm going to make a request using the syntax that we looked at before. So that's going to be passed to the Lightning Component framework. And the first thing the framework is going to do is check if it can get the data from the client cache, because obviously that will be a lot faster. Now, in this first example, the data is not available. So then, of course, the framework is going to call the server to get the data, is going to get a response, and then is going to cache that response, because remember, you mark that action as storable. So at this point, the response is in the cache. And then the last thing that the framework will do is to actually pass that response to the component by calling its callback function that you define. So that's the typical use case when the data is not available in the cache or is expired. Now let's see a second example. And in this second example, the data is available in the cache. So it may be the same component or another component calling the same server method with the same set of arguments. So once again, the component is going to make a call for that request. The framework is going to say, okay, let me see if I can get the data from the cache. And in this case, the data is available in the cache. And so we get the response from the cache, and the framework says, great, I'm going to pass that straight back to the component. And that's it. And the big win in this case is that there is no server round trip involved at all. So this is going to be super fast. Let's take a look at the last example that may be a little more sophisticated here. So in this case, the data will be available in the cache, but is not considered fresh anymore. Remember, if it has been in the cache for more than 30 seconds, and of course less than 900, then the data is there, but it's not considered fresh. So let's see what happens in that case. So once again, the component is going to make a call to the framework. The framework is going to say, okay, is that piece of data available in the cache? And the cache says yes, but it's not fresh. The framework is going to say, okay, great, in the interest of performance here, I'm going to send that response right away to the component. But just in case, I'm going to make a call to the server to see if the data has changed. And so you get a response, the framework gets a response from the server at this point, and is immediately going to cache that new response with a new timestamp. And then, this is the critical part, if and only if the data has changed since that response that we first sent to the component, if that is not the same response anymore, then I'm going to call the callback function of the component a second time, okay, with the new response. So this is what happens when the data is available in the cache but is not fresh. And by the way, this is a little sidebar here for people who are familiar with JavaScript promises. This is the reason why you can't really use JavaScript promises with storable actions, because JavaScript promises are meant to be resolved once. And the way storable actions work is that the callback function of your component may, in fact, be invoked twice. All right, so enough with slides. Let's take a look at a quick demo here to see the performance benefits that we could get. So I have a sample application here that is called Dream Invest that you can actually install. I blogged about it on the developer website like a couple of weeks ago with an unmanaged package. So it takes 2 minutes to install. And this is a kind of a financial services application. And as part of the application, there is a Fund Explorer screen here. And what this is essentially a list of mutual funds. You see that I have 500 of them at the bottom. And so you can mouse over. It's going to show you the performance of each mutual fund. And the idea of this screen is that it helps a customer find a mutual fund that is good for him or for her. Okay, so let's take a look at the console here. And you see that in the console, I print some results to kind of show how performance is going to work. So you see that the initial call to get funds, which is a server method, took around 200 milliseconds. That's for the first page. So now let's kind of navigate to the second page. And you see that in this case, it took around 157 milliseconds. And you get the idea. Now I'm going to go to page 3, 248, page 4, 300. Okay, so around 250, 300. Now look what's going to happen when I'm going back to page 3, because remember, page 3 I already retrieved from the server. So I'm going to go back to page 3, and boom, all of a sudden, the result comes back immediately, in this case like 0.3 milliseconds, so like really an immediate response. And again, if I go to page 2, which I retrieved before, again, immediate response. If I go back to page 3, very fast, page 4, very fast, page 5 that I didn't retrieve yet, again, around 150, 200 milliseconds. So that shows you some of the benefits of storable actions. Let's take a quick look at how this is implemented. This is the FundTileList. And if I go look at the helper, which is really where it's all happening, you see that this is a traditional kind of syntax to retrieve data from the server. The key here is that, as I showed you before, I marked that action as storable, and that's really all I have to do. The framework takes care of everything automatically for you. There is a second way you can implement client-side caching with the Lightning Component Framework, and that is with the Lightning Data Service. So in this case, it's not an RPC approach anymore. In fact, you don't even write any Apex. There is no controller, no Apex to write. Instead, it's kind of a managed record approach. So what you're going to do using that new tag, for us record data, this, by the way, is a summer 17 syntax. In previous releases, it was called Force Record Preview because it was a developer preview feature. But anyways, the idea is that you tell the framework, I want this record identified by that record ID, and I want these fields. And the framework is going to do what's needed to get the data. You don't want to know. This is really abstracted if you want. And at the end, it's going to give you that record in that attribute here. Now, it's important to understand really what happens behind the scenes here. So let's take a quick example where we have 3 components, maybe on the same page, right? So the first component is going to say, okay, I want this record here identified by that ID here, 1111. And I want 2 fields, name and phone. At this point, the Lightning Data Service is going to say, okay, I don't have that record in my cache yet. So I'm going to go to the server and retrieve that record. Okay, and then I'm going to return that record to component A. Now imagine that component B, maybe on the same page, needs the exact same record. At that point, obviously that record and these fields are already in the cache. So big win again here, because there is no round trip to the server involved. The Lightning Data Service can return that record immediately. And now look at that third component, because that gets a little more interesting here. I want the exact same record, but I want an additional field. Maybe in this case, I want the mobile phone number. So the Lightning Data Service is going to say, okay, I have that record, but I don't have that field yet. So behind the scenes, it's going to go fetch that additional field, and then it's going to send you the record back. All that is happening behind the scenes. You, as a developer, you really don't have anything to do to make that happen. So let's take a look at an example here. And in this case, I'm going to look at the Dreamhouse application. I hope you're all familiar with this application. It's also a simple application that you can download. The website here is dreamhouseapp.io. And this is an application for the real estate business. So for example, I have a list of properties here, essentially a list of houses for sale. And as you can see, I have a number of components here. Let's make that a little smaller so that you see exactly what's happening. Let's do it like this. So you see that here I have the main layout, so that's one component. I have a path component at the top, and then I have 1, 2, 3, 4, 5 components, custom components that I built to display some, attributes of that house. Now, the first time that I wrote that Dreamhouse application, that was actually before even the data service existed. Each of these components made their own call to the server, essentially to get the same data, like the data for that specific house. And that was obviously bad from a performance point of view, because now I had essentially 7 calls to the server to get the exact same data. So that was bad, and that's the problem that the Lightning Data Service solves. Now, all these components use the Lightning Data Service, and as a result, they all share the same record in the client cache. And an additional benefit of that, obviously, is that because they share the same record in the cache, if you modify the data in one of these components, so let's say, for instance, that I changed the date that property or that house was listed. I made a mistake. It was not in March, but it was in April. Now, keep an eye on this component here in the upper right corner that shows the number of days that that house has been on the market. I'm going to save that, and you will see that automatically this component updates with now 12 days on the market. As a developer, I didn't have to do anything, and that happens automatically simply because they all share the same record. So let me quickly show you how that actually works. In the property days on the market component, and again, this is summer 17 syntax, but it works the exact same way in spring 17. It's just record preview instead of record data. So that's really all I have to do to request the record from the framework and then be notified of changes. Notice again that in this case there is absolutely no controller, Apex controller involved here. All right, let's look at a third option for data caching at the client side. So this is not an option provided by the framework, but this is a custom caching solution that you may want to implement. And the reason you may want to do that is because you want full control over the way caching is going to work. A good example of that is when you work with very static data that essentially never changes. Of course, in that case, you could still use storable actions, but as you know, storable actions are still going to make calls to the server behind the scenes to make sure that the data hasn't changed. Now, if you know that the data will essentially never change, then you may think that that's kind of a waste of resources and implement your custom caching solution instead. So let's take a quick look at an example of a custom cache, and for that I'm going to go back to my mutual fund selector here. So what I didn't show you before is that you have a bunch of filters here. So you can filter these mutual funds. Let's say I'm going to see only the fixed income mutual funds, or I can filter them by sector. Let's choose energy, for instance. And the point is that the data in these drop-downs, come from the server, come from Salesforce, but virtually never changes. This is like super static data. So let's see how I implemented that using a custom cache. So I'm going to go back to code here. And the first thing that I did is to actually write a JavaScript class, or some JavaScript code that I wrote here as a static resource in Salesforce. So using static resource, you can create a JavaScript file And that's essentially what I did, and I used the kind of the JavaScript module pattern here. And the way it works is that you have a cache variable that's an object, and that's where I'm going to store the cache data. And then my public interface, my public API, is made of two simple functions. The first one is called setData, that lets you save data in the cache under a specific name, right? And then you have getData to retrieve the cache data identified by that name. So fairly simple, right? So like this is a very minimalistic implementation of a custom cache. So now let's see how I can actually use that custom cache. So I'm going to go in the SectorSelector, which is a component that provides the drop-down to select a sector. Now look what I'm doing here. I'm doing LTNG required to actually load that static resource, which is that JavaScript file, right? So I'm loading my JavaScript module, if you want. And then when that JavaScript module has been loaded, I'm invoking this function on the controller. So let's see what's happening in there. So the first thing that I'm doing, I'm trying to get the list of sectors from my cache. Remember that getData function, right? And if I get some sectors, so in other words, if sectors isn't null here, then I'm done because I just got my data from the cache. I can set my attribute to the cached value and I'm done. Now, if sectors is null, which means that it's probably the first time I'm trying to load the sectors, then no problem. I'm going to ask my helper to load the sectors as usual. Let's take a look in the helper. So in load sectors here, what's happening is that, as usual, I will invoke a getSectors method in my server-side controller. At some point, the data will come back. The one thing that you do in addition to the usual syntax is that now you're going to store that value in the cache so that essentially you will never have to invoke that method again, because the next time you ask for a list of sectors, it's actually going to be populated from the cache. So let's see if we can see that in action in the Fund Explorer here. Look at the console towards the top here. You see that initially the sectors, let me zoom in on that a little bit, the sectors were retrieved from the server, and that's normal because it's the first time that I asked for a list of servers. A list of sectors. Okay, imagine that I navigate to another page now, okay, just to move away from the Fund Explorer, and then I'm gonna go back to my Fund Explorer. Okay, so what you see now here towards the bottom, let me zoom on that a little bit. You see that now the sectors were retrieved from the custom cache because they were indeed already available there. Okay, so that's the benefit of using a custom cache. And by the way, since we look at the log here, you see that get funds was also super fast to execute because in this case, we got the list of funds from the storable action, so also from the client-side cache. Okay, this can really make a big difference in terms of performance. So we're done with caching. Let's quickly summarize the different options. If you're looking at caching records, maybe on a record page, then the data service is really a very good solution for that. If you're looking at caching essentially anything else, like list of items, collections, or maybe data coming from a REST service, then storable actions are a great solution for that, because storable actions don't care about what you cache. It's any kind of response that you can cache. And then finally, if you want full control over the caching implementation, that's when you want to use custom cache. Okay, let's shift gears a little bit and focus on component instantiation, which can also have a big impact on performance. Okay, so when you start with a kind of an application composition framework, when you start building components, it's really easy to be tempted to throw everything you have on the screen, to basically show every single component that you have related to an object on the screen just because it's cool. But from the user point of view, that may not be great, because that may lead to what we call here cognitive overload, meaning simply that there is way too much information on the screen, and that it's going to be hard for the user to understand the task that he or she needs to perform. So from a usability point of view, it's bad. From a performance point of view, it's also bad because you have to instantiate all these components. So the general guideline here is that you should stay away from that. Don't just throw every component that you have related to an object on the screen. That is not a great practice. Instead, a good interactive design practice is to implement what in the industry is known as progressive disclosure. And the idea here is to really focus on the critical path. Now, what is the critical path? The critical path is really the main task that you want the user to complete on that screen, and then defer everything else. And from a usability point of view, it's going to be better because you keep the user focused on the task. From a performance point of view, it's also going to be better because you have less components to instantiate. Now, what does it mean to defer everything else? What it means is that you still want, that data or these tools to be available, but maybe not on the main screen. Maybe you make these tools or the data, the information available in a secondary screen. So instead of trying to explain that too much on a slide, what I wanted to do is demonstrate how you can easily do that in the Lightning experience. And the way that kind of the technical term that we use to describe what we do here is lazy instantiation. So what it means is that you defer the creation of components until it's really needed. So let's see how you can actually achieve that by, without any code first in the Lightning experience. So I'm going to go back to my Dreamhouse sample application. I'm going to make that a little smaller. In fact, I will argue here that I was tempted to throw everything on the screen, and I did it, and it's probably not great. In fact, I have too many components in that right sidebar. Most of them I can't even see if I'm in the normal resolution of my browser. Instead, what could I have done to implement progressive disclosure? Well, there are a couple of things that I could have done. So first of all, in App Builder, as you know, you can create tabs, right? And the nice thing with tabs is that by default, the components that are behind that tab or on that tab will not be created until that tab is activated. So that is one way to implement lazy instantiation without even writing any code. Another way I can do that is using actions, like quick actions or global actions. So for instance, in Dreamhouse, I have a fancy component that lets you turn on the lights on and off, like using IoT in connected houses that you may be managing as a broker. Now that sounds super exciting, but let's face it, you're not going to use that all the time. So instead of wasting resources and confusing the user by adding that component in the default layout, I could remove it from there and maybe implement it here as an action, as a quick action. And again, when I do that, that component is only going to be instantiated when I actually click that action. And finally, a last approach that I wanted to show you, instead of putting the mortgage calculator here, again, in the right sidebar, where it would be instantiated as soon as I navigate to that page, maybe I can use the utility bar, because in this case, it actually makes total sense to have that mortgage calculator at your fingertip all the time. So these are basic approaches to implement lazy instantiation in the Lightning experience without even coding anything. But of course, you can also use code to implement lazy instantiation. So there are a couple of approaches that I want to go over very quickly here. The first one is also using a tab component. But in this case, you would use a base lightning component, the tab component. And in that case, again, the default behavior of that component is that only the components on the first tab will be created and added to the DOM. And the components on different tabs that are not initially visible are not going to be created until the user clicks that tab. So that's a very easy way to implement lazy instantiation. Another way is to use the aura-if tag. And with aura-if, as you can see, there is a condition here. In this case, step must be equal to 1. If that is true, then this component, my component here, will be instantiation. But if that component wasn't true, this component wouldn't be instantiated, wouldn't be created, wouldn't be added to the DOM until that condition becomes true. So that's another way to implement lazy instantiation. And of course, you have a third way, which is to create your components programmatically. This is a little harder to code, harder to maintain. So if you can, use one of the other options that I offered here. Now, one important thing is that when you are lazy instantiating components, it's also important to lazy load related data. So for example, if you have data that would only be visible on a second tab, don't preload the data because the user may never click that second tab. And if you preload the data, again, that is a waste of resources. Okay, so I'm going to do a little demo here to show you how you can indeed do lazy instantiation and lazy loading of data. So for that, I'm going to go back to my Dreamhouse application. And if you download the last version of Dreamhouse, there is a cool new feature here that is basically powered by Einstein Vision, and it's essentially an image-based search feature. So the idea, let me quickly demo that for you. So the idea is that you may want to search houses by picture. You may not know the exact name of a category of house that you like, but if you see a picture like this one, for instance, I'm going to drag a picture here. So I'm uploading a picture, and I'm essentially asking the application to show me houses like that. So Einstein Vision established that that's a Victorian house, and then the application shows me Victorian houses here. If I upload a house that looks very different, a lot more modern, I'm going to submit that to Einstein Vision. Einstein Vision at this point is pretty sure that it's a contemporary house, and it's going to show me contemporary houses. Now, the reason I show you that is because I've also built a little utility here in the Dreamhouse app to manage these Einstein Vision data sets. So you can have multiple data sets. A data set is essentially sample images that will help Einstein Vision to kind of predict what a specific image is. And you see here that I have 3 data sets. I could have a lot more. And a data set is identified by the different labels, in this case, types of houses. And then what you do, you kind of train that data set and you create a model. A model is just an Einstein Vision artifact, but the key thing is that to get the list of models, you actually need to make an API call to the, to Einstein Vision. Now, 2 things just happened here. First of all, that table was not created, was not added to the DOM until I actually activated, I clicked that second tab. And the second thing that happened is that I didn't make the call to Einstein Vision until you activated that tab. And that's really important because imagine here if I had, let's say, 20 different data sets and you kind of preload all the models, you can only identify them or load them by data set. I would have had to make 20 different calls to Einstein Vision to retrieve these data sets, and that would have been really bad from a performance point of view. So let's take a quick look at the code here for this interface. So as you can see, I am using a Lightning-based component here, a data set. The second tab, which was model, remember, everything that's included in that tab will only be created when the tab is activated. Not only that, but when I actually click that tab, I'm actually hooking an event handler here on models tab, and let's see what I'm doing here. As you can see, it's only at this point that I'm going to make my call to Einstein Vision to actually retrieve the data. So that is an example of lazy instantiation and lazy loading of data. Another thing that you often need to do in an application is to render elements conditionally. Sometimes they need to be visible, sometimes not. Now, there are two traditional approaches to implement that. The first one is to use CSS to simply hide and show elements. And the second one is to conditionally create these elements using aura-if. So to kind of give you a concrete example that we can use as an example here, let's quickly take a look at an example where you really have to conditionally render UI elements. And for that, I'm going to go back to my mutual fund explorer. And as you can see here, there is an InvestorProfile tab. And this is maybe, a kind of a wizard interface that I use maybe as a broker to capture the profile of the investor that I'm talking to. So as you can see, I can navigate through that wizard. I have next and previous. Okay. And the basic idea of a wizard is obviously that there is only one panel visible at any time, right? So that's the basic idea of a wizard. So now there are different ways I could implement that. So let's take a look at options. So the first option is to use CSS, right? So I have the panels, there are 3 divs here, and if the step, so I have an attribute that keeps track of the current step. Let's say that the current step is 1, then I'm not going to add any CSS class to my div, so it's going to display fine, and I will see all the components inside that div. Because step is currently 1, then obviously this condition is false, and in that case, I'm going to add the SLDS hide to that div, which is basically going to hide that div, and same thing for step 3. Now, the key thing to understand here is that even though these elements are hidden, they are actually present in the DOM. They are created in the DOM. And more than that, imagine that inside these divs, you actually have event handlers. These event handlers are live. They are working, okay, even though the UI is not visible. So the second option you could use to implement the same wizard is to use aura-if. And in that case, it works the exact same way. So I have an attribute with the current step. So let's say the current step is step 1. All the DOM, all the elements inside that aura-if will be created and added to the DOM. Now, this condition evaluates to false because the current step is 1. Any element inside this aura-if will not be created, not be instantiated, not added to the DOM. And obviously, if you have event handlers defined here, they are not live because they are actually not created. Okay? So let's kind of summarize the 2 approaches to conditionally render elements. So how about the initial load time of a screen? Well, using CSS, it will probably be slower because all these elements are created up front. Whereas with aura-if, you only create the elements where the aura-if expression evaluates to true. The size of the DOM is going to be bigger using CSS. And the simple reason is that, again, you create all the elements up front. And something that can sometimes generate unexpected behaviors is that you could actually end up with what I would call here ghost event handlers. So these are event handlers that are set on elements that are not visible in the UI, yet they are wired so they can actually react to specific events, and that can generate unexpected behavior. Obviously, with aura-if, that doesn't happen because these event handlers are actually not created. So the general guideline here, and there may sometimes be exceptions, but the general guideline, the starting point, is that you should always prefer aura-if for all the reasons that are mentioned on this slide. Okay, so let's move on to the next chapter here that's also really important. And this is about data binding. And as you know, in the Lightning Component Framework, we actually have two ways to implement data binding. Bound expressions that you implement with curly exclamation mark, and then unbound expressions that you implement with curly hashtag. Okay, let's take a look at bound expressions first. So bound expressions are essentially a way to implement what is known as two-way data binding. So I'm going to use a simple example here where I'm iterating through a list of contacts. So I display a list of contacts using aura iteration. And let's say that for each contact, yeah, the user can modify some fields. In this case, I only put to the first name and the last name. Because this is implemented as a bound expression, in other words, two-way data binding, you may not always realize that, but behind the scenes, what the framework has to do is to implement two event listeners for each bound expression, right? The first one is on the model, so on the data. And you're basically saying here, if the data changes, I need to know. So I'm setting up an event listener. And if indeed the contact changes, then I need to change the value in the input field, right? And the second event listener that you have to set is kind of the other way around. If the user changes the value in the input field, so I need to know that. So I'm going to set an event listener on the input field. And what I'm going to do then is update the data with that new value that the user typed in the input field. So it's always important to keep that in mind. And by the way, this is simplified code. This is pseudocode. It's a little more complicated than that in the framework. But the key thing is that every bound expression basically generates two event listeners. And that is why the example that I used here is a loop or an iteration, because you can see how it can, multiply pretty dramatically here. So the second option that we have here is unbound expression. And in unbound expression, it's not two-way data binding. It's even not one-way data binding. It's really important to understand the difference here. The difference is that it's one-time data binding. In one-time data binding, the value is only set once. So in other words, when you go through the iteration here, it's gonna set the value once, and then there will be no lingering event handler. All right, no lingering event handler. So this may not always be the best solution. Obviously, if you need to keep track of changes, if it's if it's a read-write type of interface, it may not be the right solution. But for a read-only solution, it may actually really help. So the goal being to minimize, obviously, the amount of event listeners that you create. It is really important to understand the difference between one-way data binding and one-time data binding. For instance, here is an example that would not work with unbound expression, with one-time data binding. So the example that I have here is a typical, you're going to retrieve a record and then bind some UI elements. So I have an attribute here with a contact object. I have my Lightning data service, and then I'm binding some simple UI element to that attribute. Now remember that every call to get data is asynchronous. So I'm not going to get the data here immediately. So the first time that this is going to render, I'm going to use that default value of contact, which at this point is null or empty. So basically, I'm going to set this value, the UI element, to nothing, to null. Okay, so nothing is going to show. But that's the one time I already set a value. So at this point, there is no listener lingering anymore. So when finally, force record data comes back with the record, there is no listener here to update that UI element. So, the value is not going to show. So it's important to keep that in mind, the difference between one-time and one-way data binding. Also, something else that you may consider, sometimes data binding may be overused a little bit. And if really all you need to do is have a parent component invoke some kind of a method in a child component, well, you can actually do that using something that we call Aura methods. So in the child component, you can define a method, show pop-up with a number of attributes, and in the parent component, you can actually invoke that method in a traditional API way. And in this case, you wouldn't use data binding. So if it's just a method that you want to call, maybe there is another option than using data binding for that. All right, so that was data binding. So for events, we're just going to quickly review a lot of the things that we already covered. So the key thing here, the key guideline, is to limit the number of event handlers. And we just covered, some basic guidelines. For instance, use unbound expressions when possible, and especially in loops, because in that case, the data is available. So loops or iterations are really a good place to use unbound expressions, to use, the curly hashtag syntax. Then if you use Aura if for conditional rendering, you're also going to limit the number of event handlers, because you're not going to have these ghost event handlers that I described before. And then another kind of approach to limit the number of event handlers is to let events bubble. So let's look at an example of that. But before that, let me also remind you that you should also limit the number of application events that you're using in your application, and always prefer component events when possible. In fact, application events should be limited to high-level communication between components, and the typical use case for that is App Builder. For everything else, and I'm going to give you an example of that, you should really prefer component events. So let's take a look at an example here. So I'm going to go back to my mutual fund explorer. And remember this, right? When I mouse over a specific mutual fund, I can see details. And then remember also that I can navigate through different pages here. So let's see how these two things are implemented in the components. So the first thing that you notice is that, so this is FundTile here. I didn't connect or register event listeners here, which may be the first thing that you would think of doing, right? So the mouse event listeners, well, I could do that, but then you would actually register event listeners for every single tile in that list. So instead, what I did, I went one level up on the UL, on the list, and registered my event listeners there. So I have only two event listeners instead of 2 times n being the number of funds that you would have in the list. And the second thing that you notice is that for that paginator component here, I'm obviously not using an application event, I'm using a component event. This is very similar to the on-click event on a button, right? Previous page and next page. And here is in Paginator the way you actually define these events, these component event, register event, but in this case you provide a specific name, actually using the exact same event behind the scene, but this is the way you declare these events that can then be used on the component when it's used in a parent component. All right, so we are almost done. There are a couple of things that I need to quickly remind you of. The first one is to really reconsider the use of JavaScript libraries. So there are cases where the JavaScript library that you are using may not be needed anymore. I'm thinking specifically about DOM manipulation libraries, like jQuery, for instance. Even though you technically can use jQuery, the question is, should you, and what is the impact on performance? It used to be that we couldn't live without jQuery for all the DOM manipulation utilities that it provided, but the reality is that JavaScript has become a lot better, in fact, borrowing a lot of these utilities from jQuery. And also that frameworks like the Lightning Component Framework provide a level of abstraction where you don't really need to manipulate the DOM directly, and oftentimes it's actually considered an anti-pattern. So take a second look and make sure that you really need all these libraries that you're using, because obviously they add to the bandwidth that your components are using. Same thing, for instance, for UI libraries, like I'm thinking, Bootstrap or jQuery UI. These are cool libraries, but they have their own UI identity, and the reality is that now SLDS provides many of the same features that these libraries provide. So once again, reconsider, make sure that you need these libraries. If you do, then make sure that you're using minified versions of the JavaScript library and potentially the associated style sheets. Talking about UI components, as you may know, there are really two kind of packages or two namespaces of two sets of UI components available with the Lightning Component Framework. The first set of components is in the UI namespace, so UI buttons, for instance. These are the components that we released initially as part of the Lightning Component Framework. And then there is the new set of components called the base Lightning components that live in the Lightning namespace. So for instance, Lightning button. The general guideline here is to use the Lightning namespace. There are many benefits, but just to name a few, they automatically have the native Lightning look and feel. They will be faster because they already live at the client side. They don't need to be downloaded initially. They are already part of Lightning experience. And they are also faster because this is where the engineering team is really focusing on, performance optimization. That's also where you can expect innovation. New components are coming to that specific set of components. They are made to be accessible. And finally, the latest in terms of client-side validation is provided in that package. All right, just to conclude this presentation, I really wanted to include this because I get a ton of questions all the time about development settings versus production settings. So let me actually go in setup to show you these two settings that you really need to be aware of. So if you go in setup like me, and you are going to type here, say, Lightning components. Okay, you're going to have a list of all your Lightning components. In development, you should enable debug mode because it's going to give you a lot more information about potential issues in your components. So that setting should be checked in development mode, but don't forget to uncheck it when you go to production because, again, that's going to have an impact on performance if you leave it checked. Now, my favorite one that a lot of people are struggling with is when you are in development mode and you modify a component, then you try it, you refresh your browser, and it's still showing you the old version of that component, and you keep hitting refresh, and you wonder why it's not showing you your changes. That is because in the spirit of performance, we actually cache components at the client side so that we don't always have to go back to the server to load the definition of a component. Now, during development, this could be pretty annoying. So what you can do in setup, you look for session settings, and then there is a setting here, enable secure and persistent browser caching to improve performance, right? And this one, you're going to uncheck during development. And that automatically will make sure that your changes will take effect immediately and you don't have to keep hitting the refresh button all the time. All right, and finally, how do you actually measure performance? There are a series of tools that we don't really have time to cover in this webinar. This could be a webinar in itself, but just to point you to some resources, Of course, you can use the Chrome developer tools, and the Chrome timeline specifically is super useful. We also have a Chrome extension that is sometimes a lot more useful than Chrome timeline because it's aware of the Lightning component framework and can give you more insights in terms of what's going on. And finally, the communities team also has a tool called the Optimizer. If you go to my recent blog post about performance best practices, you'll find more information about these tools, and you will also find links to point you to these specific resources. So that does it for this presentation. A lot of topics covered here, from data retrieval to component instantiations to specific UI components to use, again, as reference materials. You can go take a look at the blog article that I mentioned before, but there are also a couple of Trailhead modules that you can take a look at. For instance, building an account geolocation project. There are different Lightning components, modules, and projects that you can take a look at. Finally, I need to mention one thing. All the developer evangelism team, the product teams, we're all going to be at Trailhead DX at the end of June, June 28th and 29th. And there will be a ton of technical sessions and developer sessions. This is our developer conference, so we would love to see you there. Obviously, as expected, there was a lot of materials to cover, so we went a little long, but we can stick around for a few minutes. We'll try to answer as many questions as we can. If the question that you have is unanswered, always try Trailhead, because there are a lot of topics that are answered there. And of course, you can also go on Twitter and ask questions there. But what we will do, we'll take the questions that we didn't answer and answer them in a blog post. So Arabella is going to help me with a few questions here. Let's go.
Okay, there have been a flood of questions. It's great to know that so many people are curious about this topic. And thank you again, Christoph, for going into this so in depth. I'm sure we could blow out any single one of these topics into its own webinar moving forward. Yeah. But let's dive in, and we've got about, we can go about 5 minutes over. So let's dive into the first question that we have for you, which is, can you change the refresh age and expiration age for storable actions?
Actually, you cannot. So these are values that are set in the framework, and by the way, they are also subject to be changed. I just wanted to kind of give you kind of more in-depth information, what's going on behind the scenes, but currently they cannot be changed. One more thing about that is that these values are actually different when you use the Salesforce One mobile application.
Okay, that's a nice lead into the next question that we've got, which is, do storable actions work in the Salesforce One mobile app?
Absolutely. So, as any Lightning component, the Lightning components that you write for the Lightning experience work in Salesforce One. So the only difference, as I mentioned before, is that the values for refresh age and expiration age are different. In fact, I specify the exact values, I think, in my blog post. So if you're interested, go read that blog post.
Okay, lovely. Your blog posts are always great. So I'm sure everybody here will be reading them again after this. So the next question is there a performance impact when using the Lightning container component?
All right, so the Lightning container component, for people who are not aware of it, is a new component that was introduced in Spring 17, I think in developer preview. But essentially what it does, it lets you load components built without a framework. So you could have a component written with AngularJS or React, and load that in the middle of the Lightning experience. And if you use the Lightning design system, they will look exactly like the native experience, so the user wouldn't see the difference. So the question is there a performance impact? And I will answer that saying yes and no. It depends how you use the Lightning Container component. If you really use these components in App Builder as kind of building blocks, right? And you end up with, let's say, 5, 6, 7, let's say AngularJS components, for instance, in a page built with App Builder. Behind the scenes, the Lightning Container component uses an iframe, which also means that Angular and maybe all the other libraries that you may be using will be loaded multiple times. So if you have 6 components written with AngularJS, the AngularJS framework and related components will be loaded multiple times. Maybe cached, so it may not be that bad, but there is definitely a performance impact there related to the iframe. Now, if you are using an AngularJS component as a kind of a full screen component in the Lightning experience, then I would say the performance impact you won't even be noticeable.
Okay, so the performance impact is something to bear in mind. Another thing that is on a lot of people's mind is security. So can you please answer the question of, will the custom cache approach work with Locker service?
Yes, it will, assuming that you're not doing things that you're not supposed to do. So Locker service makes sure that your components are secure, that the components could not, for instance, kind of have access to data and then post the data to a third-party website. So a Locker service is very efficient to do that. But there are a lot of, not a lot, there are a number of constraints to make sure that these components are safe. So for instance, Locker service doesn't support JavaScript evals. So if you do unsafe evals in your custom cache implementation, then in that case, it's not going to work. But for the most part, it should work totally fine because, again, it is just JavaScript.
Okay, thank you for answering that. Unfortunately, there are so many more questions, but we'll have to answer them in a follow-on blog post on developer.salesforce.com/blog. But thank you all for your interest and for attending this webinar today with Christophe. Thank you for joining us today, Christophe.
Thanks, everybody.